Hello, everyone. Welcome back to the second part of my Docker learning series. I'm super excited to have you all here. And today it's going to be a lot of fun because we are going to actually use the concepts that we learned yesterday, the basics of Docker, and then we will carry it forward to write our own Docker files, which are actually used to containerize our own application. So yesterday we just used the public images, but today we are going to build the images for our own application. So that's going to be a lot of fun. We also have a lot of other stuffs, which I will just cover in a second. In the meantime, I'm super excited to have you all here. If you have joined the yesterday's session, please let me know in the comments. And even if you have not, then this might be easy for you to follow along as well. Hi there. Hey, Cynthia. Welcome, welcome. We have Suyos as well. Welcome to the stream. I hope you are all having fun in this Global Hack Week, and we will continue to have fun throughout. All right, so let me just quickly pull up my screen. Okay, I hope you can see that. And now let's begin the session. All right, so hi everyone. Once again, I am Sagar, and I work as a coach here at Major League Hacking. And professionally, I also work as a DevOps engineer, and I work to build different cloud and DevOps solution on different cloud service providers for our clients. So mostly getting the things that our client built to the end user. So that's our end goal here with me. And also, I'm super excited to start my master's degree at the Technical University of Munich this winter. So super excited for that as well. Hi, Abhinak. Welcome to the stream. Super excited to have you all here. All right, so just going through the agendas. Oh, all right, also you could catch me up on Twitter and Instagram. So if you want to connect with me as well, so here are my handles. All right, next up, again, welcome to the Container Land. And I call this as a Container Land, the series, and I'm super excited to have you all once again. So if you followed yesterday's session, you already have this. But if you are joining for the first time, then please make sure to bookmark this specific link because it has all the resources. It also has all the commands and important instructions that you will need to follow along when you are watching the session, because typing by watching might be difficult. So I have provided all the instructions in this Notion page. So please make sure that you bookmark this session. Another important thing for this session is that this was the standalone session which I did yesterday itself. So before the Docker session, I also did a sample web deployment session. So where I took a Monstack application, so MongoDB, Express, React, and Node.js application, and I deployed that to Microsoft Azure. So I would also recommend you to watch and follow along this session. So again, this link has all the information about that particular session, and it also has the recordings from that session. So you can watch and follow along. The reason that I mentioned this session in the Docker session is that we are going to use the same code base. So the application that we used over there, so it's going to be the same that we use for this specific stream today, because we are going to take that sample month application, and rather than just pushing the code directly to the Azure using GitHub Actions, we are going to containerize it first using Docker. So that's the change that we'll have today. So I would highly recommend you to bookmark both this lessons, and because it has all the resources and the instruction that you will need. So firstly, the Docker MLH resource, which is for today and tomorrow as well. We have the part 3. So this has all the resources. And also please follow the Mon deployment automation session, which is also highly recommended. All right, so just doing a few recap of the things that we did yesterday. So this was part 1. We covered all of this yesterday. So we introduced about containers and Dockers and why do we need them. Then we saw some of the basic Docker commands and the life cycle, such as how to start your container, how to stop your container, how to pull image from Docker Hub, and how you can create them, how you can remove them. We also talked about Docker networking, and we talked about the bridge versus the default bridge versus the user-defined bridge network. We also talked about how you can add storage or persistent storage for your Docker containers using Docker volumes, and we had a demo of all of that. So these are the things that we covered yesterday. And again, if you had not gone through that session, please follow the resources that I just said before, and you should be totally fine. So for today, that's going to be part 2, and which is happening right now. So we'll take this a step further, and we'll start writing our own Docker files. So for the sample one application that I just mentioned, so we are going to write the Docker files for that one. And then once the Docker file is written, we will build the application image. So Docker file, we will talk about that in detail just a second. So Dockerfile, those are mainly used to create our own Docker image. So we will, once we have the image, we will publish this image to the private container registry, which is again going to be hosted on Azure using Azure Container Registry. And we'll also talk about Docker Compose, which is another amazing Docker tool, which is used to run multiple containers. So once you have a lot of containers, then things start to get difficult. So you can use Docker Compose to simplify that a bit. And tomorrow we also have the part 3. So we will finally learn, this is going to be the final session. So we'll learn how to deploy the container. So once we build the container image for our own custom application, we are going to actually deploy that container to Azure using Azure Container Apps. And that app is going to run on the cloud so that the end user would be able to access our application. So that's going to be the entire process. And along that, we will also set up a full CI/CD pipeline so that we will skip or it will automate the entire process of building your Docker image and publishing it to Azure Container Registry, and then finally taking that images to the Azure Container Apps and running it. Yeah, so we do have an amazing question from Cynthia. Let me pull that up on the stream as well. So can we do all of this in Azure Free Tier? And the answer is yes. There is a specific tier for students known as Azure for Students. Again, if you follow the link that I provided earlier in the Notion, you will get the link where you can sign up, or you can even do a quick Google search for Azure for Students, and you will get a $100 credit. So that should be more than enough to cover everything that I will show you today. So please just be careful when you select the different tiers for the services. So there are always the free or the limited version tiers, and also there will also be the advanced or professional tiers. So always select the one that is the most cheaper one. If you follow my stream, then I will also show you which option you need to select to be extra careful. And once you are completed with the demo, or once you are completed with the session, please also make sure to delete your Azure resources so that you don't spend all your Azure credits. So yeah, a good question. I hope that answers your query. So let's get started. So first, we are going to talk about how we can create image. And for that, we need something called as Dockerfile. All right, so Docker, basically when we have our application, we just have our source code, right? We have our source code, and like I mentioned yesterday, for our app to run, it does not only need our source code, we also need a runtime environment. So if you are building a JS application in backend, you normally use Express or Node.js. For Python, it might be Fast API. So you need that, right? You also need the respective programming language to be installed on your host. So if you are running a Python application, you need to have Python installed. Needless to say, that's pretty simple, right? For a JS, you need to have the Node.js installed. For Java-based application, you need to have Java virtual machines and all those things installed on your machine. And also you need some of the operating system packages. You also need the application dependencies. So your packages, third-party libraries, that whatever you might use. So and an application is comprised of all of things, right? So we need to tell Docker. So if you want to package all of that into a single unit, which is known as a container image, we need to tell Docker exactly how you can build that application in a step-by-step manner, right? And we write that instructions in a file known as Dockerfile. So that is the name of the file where we tell Docker how you can actually build or the image that we need for our application to run. So we'll give them step-by instruction. It is very similar to how we actually run the application in our own machine. So let's take an example of a Node.js application. So we normally have our code. We install Node.js first, and then we do npm install to install all the packages. And then once we have the package installed, we build the application if it's a build process. And if it does not have, then we simply do npm start or npm run to start the application, right? So Dockerfile also follows the similar process, but there is some changes that we need to do, and it is written in a different manner. So I'll show you exactly how you can write that. So once you have the Dockerfile written, you can simply build the image by using the Docker build command, and then you provide it a tag. So that's going to be -t flag, and you are going to give it a name and a tag. So let's say you have your backend application, so you can name it whatever you want. So my backend or my application or whatever name you want, and then you need to give it a specific version as well if you want. So yesterday we talked about this, right? So this is going to be the name of the image, and what is separated by colon is the version. So for the first time you can start with 1.0. So every time you make some changes to your application and then you build the image, you can increment the tag version to reflect the latest changes. So next time it's going to be 1.1 and 1.2 and like that it follows along, right? So that's going to be the Docker file. And another important instruction that you need to follow is that whatever you put in, if you don't want anything, so you might have your APIs keys, or in our application also we use some of the environment variables to connect to our MongoDB. So we use the MongoDB string in our environment variable, which is not pushed to our GitHub repo, because we don't, and we never push the secrets and environment variables and also the node module packages into the GitHub repo, right? Because those are only needed in runtime or build time, and that's going to be handled by the CI/CD pipeline. So normally, if you don't want anything that if you don't want something that you don't need for your container, then you need to put that in a file called docker ignore, and you need to put this right where you put the Docker file. So in the same label of the directory where there is Docker file, you also need to put the docker ignore file. So, and there you need to specify the things that you don't want in your container. Otherwise, once your container is built, if it's a public container or a public image, or when you run it, everyone who has access to that image can also see the secrets that you have, or any files and any folders that you use to build that image. So they can do reverse engineering to get access. So please don't put any secrets. And it's similar to git ignore. If you have used that, I guess most of you already are aware of git ignore. All right, so let's see a quick example. By the way, this is going to be just a brief theory. I'm going to show you exactly how to do this in our own code. So for now, just bear with me. I'll go over this briefly, and then we will have the live demo as well. So this is how a simple Docker file would look like. And it always starts with a from instruction. And this is for a Go application that we have. So you can see that it is taking a publicly available. So the first line, this is what we have already covered yesterday. So by default, whenever you use Docker and you pull the images, it always looks that image in Docker Hub, right? Which is the official repository to host and store Docker images, right? So all the public and third-party tools that you might need, so they are most likely be gonna available already there in the Docker Hub. So we are pulling up the Golang base image. So this is going to be based off upon Alpine. So what this ensures is that there is a Alpine, which is a Linux based distro. So there is going to be a Linux Alpine environment, and then that Linux image, which is based on Alpine, will also have Golang installed. So this image has that. And secondly, we use the work directory command. So or the flag. So work directory will actually create a folder inside a container. So what this will do is that so whatever instruction is there below the work directory command. So we have different instruction, right? So we have the copy instruction, different run instruction, and the entry point instruction. So whatever is there below the working directory instruction, so that is going to be executed in this specific path inside the container. So that is what the work directory does. So we are setting up a work directory /src, and this is going to be a path inside the container file system where the instructions below will be executed. And then we are copying files from our source. So the copy instruction is always in a syntax of source and destination. So the first one is dot, and this dot represents all the information that all the files and folders that is in the same root label as the Docker file. So if I have my application and everything is inside, let's say /app folder, right? And the Docker file is also inside that. So it will copy everything from the /app folder from my host machine or wherever you are running this Docker command into and this is going to be the destination. The second one is dot, but since we already set the working directory as /src, and this is the path inside container, so this will be copied. Whatever I have in my current directory, it will be copied to /src folder inside the container. So that is what is happening over here. And then we are just running the some Go commands. This is simply like whatever the command you normally type in your terminal. So like I already gave, right, example earlier, npm install, npm start, so things like that. Here we have go mod download. So this will download the Go dependencies, and then we are going to build the client first, and then we are also building the server. So it's building both the client and the server. And finally, we start the Go application by going to /bin/server. So that's the binary for the server, which is going to actually start the application. So that is how a very simple Docker file looks like for Go application. things will be more clear when we have this in demo. So I hope that's provided you a good overview, but yeah, things will be more clear. Yeah, we also have Jisan. Hi, Jisan over there. So let's continue with the session. And then a very interesting fact about Docker is that, so once you write a Docker file, the builder that is already, that comes out of the box with Docker engine, so it actually breaks that into multiple layers. So you can see that when you have an image, right? So we build an image out of the Docker file, right? So earlier I showed you the command, right? So we can use the Docker build command to actually build the image, and then we provided the path of the Docker file, right? So here you can see that the name of the image is going to be Avengers, and then the version will be 1.0, and this dot here represents the path to the Docker file. So if you have a Docker file in different application, or if you're running this command from a different path, then you need to provide the full path to the Docker file. So we do that. So it takes this Docker file, and then it builds the image, and that image is going to be break up into different multiple layers, and each line is in Docker file is going to be a separate layer. So that is super important to know, that every line that you write in Docker file is going to be a separate layer, right? And the first line is always going to go to the bottom of the layer, so it goes line by line from top to bottom. So first Docker execute, like it takes this instruction and then builds the layer for this, and then second, and then third, and then fourth, it goes like that. So from top to bottom, it builds the layer, and always the first instruction is always going to go to the bottom of the layer, right? So that is going to be the first layer. And then what is the benefit of this is that, so um, since it is break up into multiple layers, so you can do a lot of caching. So let's say in one of the layer you already copy the, or you install the dependencies, right? So next time, so let's say you are only making some changes in one of your file in the code, but you are not changing, let's say, the package or the dependencies, right? So Docker can actually just look up the layer where the application code was changed, and it can reuse all the other layers. So it can reuse all the layers that was below the layer which was changed. So every time if there is a change, then all the layers which is below the change will not be executed again. It will be reused from the last image. So, and that will reduce a lot of our build time. Things will become more clear once we have our demo. So that is a super important fact. It's used to reduce image size and also fast building. And since a good tip for you all is that to minimize or try to write the Docker file as clean as possible, because the more number of lines you have, the more number of layers will there be, and Docker will take additional time to build your application. But there are a lot of other best practices that you can follow to make sure that it's easy for you all. So the concept that I was talking earlier, so you can see that caching layers, we can use that concept to speed up our build time. So whenever we build an application image, it's going to take some time, right? Because it is executing all the instruction that is there in Docker file and then building the image accordingly, right? So it's going to take some time. So in order to make sure that the speed time is reduced, we want to have that, because when we deal in production, when we want our container to quickly start up and spin, so we don't want to wait for a long time. So that is why we want to have a minimal build size and startup time. So in this example, you can see that first we are just taking the base Golang based out of Alpine. So there will be an Alpine Linux layer, and there will be Golang installed in it. So we are just setting up a directory. We are copying all the code, and once we are copying the code, we are downloading the package. And this is often a bad practice, and I will tell you why. Because once you copy the package, so let's say you just change some lines in one of the files in your application code, but you did not have any changes to your dependency. So you did not add any extra dependency, or you did not remove the existing dependency, right? But next time when you try to do Docker build, Docker will just cache the topmost two layers, because it will the instruction did not change. So we are again using the same base image. We are again setting up a same directory, right? So this two did not change. So it is going to cache that. But since in the third instruction, it is copying everything that was there in the source, and then it is pasting that to the src directory in container, right? But this layer was changed, right? Because we changed a file in the source directory, right? So we changed a file, a source code, so that was changed. So since this layer is changed, now everything below that will be executed again. But please remember that we did not change any dependency, right? So again, it will take a lot of time to download a lot of packages. So this is redundancy that we have introduced in our Docker image, because we just changed one file. So we could have skipped, we could have reused the same packages, but we are doing it again because Docker, like I said, it will execute one by one, and only the layer. So once the layer which had changed, everything below that will be executed again. So since we already changed the source file over here, everything below will be executed again, and that's not a good practice. So what we do instead is that we change the Docker file to look it like that. So first, the first two lines are same. So base directory and then setting up a working directory, base image and working directory. So what now we are, what we are doing now is that we are copying first the package only. So instead of copying the entire thing, so here we were copying the entire source code, right? So including the package file and everything into the container, right? But now we are just first copying the packages only. We are copying the go.mode and go.som into the container directory. So this dot here represents the container path, and it will be dot slash src because we set it as a working directory. And then we do run go mod download. So this means that we first install the packages in our container. We don't have our source code here. Please remember that we are only copying the source code after we install the package, right? So first we just copy the package file, we install the package file, and then the dependencies, and only after that we are copying the rest of the code. And this is very useful because now imagine the same scenario. Next time we make changes to our source code, the top four layers are going to be the same, right? Because we did not change any dependencies, because the go.mode or go.som file was not changed. So that is why the top four layer is going to be cached, right? So Docker will cache that, and it will reduce the PC. It will reuse the layers, and it will reduce your build time, because only the fifth layer was changed. So only the things that are after the fifth layer will be executed again. And instead of obviously just copying the source file and then running the go instruction is much faster than downloading all the dependencies. So this is how you normally cache different images, and that is why you need to be very careful when you write your Docker file. I hope this is very clear to you all, and please let me know in the comments if you have any questions. I can debug that in the demo. So now let us go ahead and see this in action in the demo. All right. Okay, so just I was talking earlier, like please bookmark this session. This is the Notion file that I was talking about. I'm going to provide you the link as well. So that's going to be bit.ly and docker.mls in the comments. Yeah, please go ahead and bookmark this URL, because it has all the resources that we will be using today. And also there's the other resource, bit.ly Plasmon deployment, right? So this was the yesterday's session, where we deployed our application to Azure without using Docker, but this is helpful because we are using the same code base. So if you want to understand how the application is structured, please go ahead and watch that after this series as well. But I'm going to talk as much as I can in this demo about that as well. So yeah, so let us go ahead and see what we have over here. So we covered the part 1 yesterday. We did all of that. So let us go to part 2. And then we have the instructions over here. You can follow all the instructions that I will be using today in a step-by-step manner. So this is for you and not for me. So let us go ahead and start the demo. All right. So this is the application that we will be using to containerize. So please go ahead and clone this application. The link to the repo is in the Notion page that I just bookmarked. So if you go there, you will be able to find the link to this GitHub repo. And it has readmes and every instruction to understand like how this application is structured and what we are going to do. So let me open up my VS Code, and here I hope it is big enough for you all to see. So this is basically the application that we have. It's a Monstack application. The front end is in React and the back end is in Express. So the backend code is inside the app/server directory, and the front end code is inside the app/client directory, right? So that is pretty much simple. So in order to run this application, you just need to do a couple of steps, which I have mentioned in the respective links that I provided, right, for the Notion pages. To understand how to set up this application, please follow the bit.ly/mon deployment Notion page. You will be able to set up this project, or just follow the README in the GitHub repo as well. All right. So basically, what we needed to do there was we needed to create a MongoDB at last, because since our application uses Mongo and we are using it on cloud. So I created a MongoDB account, which, by the way, you can use it for free as well if you are using the free tier. And then I set up a project, and then I created a database cluster, which is very simple. Just follow the steps in the Notion page. And then once you create the cluster, you need to connect it to your application. And for that, you can click on connect, and under drivers, you will be able to get the MongoDB URL link that you will need to paste it in your application. And just remember that please you need to replace the URL username and the password. So you will get this when you set up the MongoDB Atlas, and you need to replace this with the actual values that you get. And once you have those values, you need to put that under the server and config.env. There is a you need to create a file called config.env, and under Atlas URI variable, you need to actually have the full value that you just copied from MongoDB Atlas. Please note to remember this needs to be replaced by the username that you create, and this is going to be the password that you create, and you will get this when you create MongoDB. Please follow the instruction in the earlier Notion page. But for to understand this demo, just you don't need to understand a lot of these things, because I'll show you how you can actually build your application. So this was about how you can run your application, and for the client side, we also have a .env file in client, and this needs to be populated with the port where your backend is running, because your front end needs to connect to your backend, and your backend here will run on port 5050 by default. So you need to provide it the local host 5050 port in order for your front end to connect to your backend. So that is what is happening over here. So now let us try to write the Docker file for our application. So I will open up the Docker file, which I have already written for you all, and I will explain everything that is over here. So this is how a Docker file will look like for our server, which is based on Node.js. So again, we are starting with a from instructions. Please note that this is very important to understand if you want to learn more about Docker, or if you use this in the future as well. So any Docker file will always start with a from instruction. And here we are taking the publicly available node image. So this image is already there in the Docker Hub, right? So if I can quickly show you that, let me pull up my browser, and I can go to Docker Hub, which is the official repo for Docker images, right? And I can search for, let's say, Node.js in this case. All right, let me search for Node.js. So this is not the one that, just a second, Node.js Docker. I will search in Google, and we have the Notepad image over here. So this is the official one, and please always look for the Docker official image tag. If you're using a popular tool, there is likely going to be an official image for that. And you can check out how you can pull this, or what is the name of the image, and also the different tags, right? So we have different tags that you can use. So the one that we're using, I guess, is 20, right? So the 20.-alpine. So this is the tag that we have. And in the second line, so these are just the white space. The white space will be ignored, and we have whatever is there in hash. These are the comments. So this will also be ignored by Docker when it actually builds the image. So in the second instruction, we have the working directory. Like I said, this will be the path inside the container where all the instruction below will be executed, right? So whatever you do below the working directory will be based on this directory itself, right? So in the third, we are using the copy command, right? So just okay. So in the third instruction, we are using the copy command, and we are copying the package.json, which is the dependency file for Node.js application. So for Python, if you are using Python based application, then that's going to be your requirements.txt file. So things might change depending on the application stack that you use. So you can file the sample Docker file in the official Docker documentation as well. For different kind of application, you will be able to find what the Docker file looks like for a typical application, and you can use that to customize it to your needs. So in our case, we are copying the dependency file, the package.json and the package log.json. So star will take whatever files which matches this pattern. So it will take both the package and the package log, and it will copy that inside the container. So this is, I could just use this dot as well, because we already set up a working directory as slash. So this will be copied inside the slash app directory, but this is also referring to the same directory. So that does matter. After that, we are installing the dependencies, right? So since we already use Alpine based image and it has the node installed in it, we can run the npm instruction, and this will install all the dependencies, and it will only install the dependencies which are required for production environment. So you can skip this flag if you're trying to use it for development purpose, but if you're trying to publish this image to production server, then you can use the dash only production flag. So now once we copy the package, and then once we install the package, we are now copying the rest of the application file. So everything inside the server folder, right? Because please remember the location of the server. It is inside /app/server directory, and then we have the Docker file, right? So that is why it will copy whatever is in the context of the Docker file. Since we are using dot, so whatever is in the same label as Docker file, all of this like database folder, routes, and everything will be copied. And this will be copied inside the, again, the slash app directory. Dot here refers to the slash app directory inside the container, right? And please, I already told about Docker ignore. So whatever you don't want in your Docker file, you need to put that in the Docker ignore file. And here you can see that we put the config.env inside the Docker ignore file, because the config.env has the URI secret of the database, and we don't want that to be inside Docker image, because once the Docker image is published, and if someone has access to that, then they will be able to see this URI as well by looking at the different image layers. So we don't want to put any secrets in Docker file. Instead, we will put this, we will inject these environment variables at runtime. When we actually run our application in Microsoft Azure using container apps, we will set up the environment in the CI/CD pipeline that automatically does this for us. We are not going to put it in the image. By the way, you could also and you should actually also ignore the node modules in Docker file, because we don't want the Docker files, the node modules which are already pre-built or existed in our local, because that's anyway is gonna be installed once you run the npm install command. There is always going to be a node module file inside your container, so you don't need to copy the node module file from the host to the container, because we are doing that already inside the container, right? I hope all of this is making sense to you up until now. And there again, we are setting up some environment variables. So like I said, we need two environment variables for our application to run, right? So the Atlas URI and the port where our server will listen. So if you go to server.js, then you can see that it listens on the port variable, and the port value is set to 5050 by default, so 5050 by default. Or if we provide it exclusively by using the environment variable, then node will use, express will use that environment variable, that port instead. So since we need these two variables, we are going to also set a dummy variable. So this is just um, as a placeholder, because ultimately we are going to replace this with the actual value when we build this in CI/CD pipeline. But for now, these are just the dummy values. These are not the actual values that we want, because when we use the Docker run command, so instead of providing this value as a build time, we don't do that because it is going to be cached in the image layer. We don't want that to be exposed. We actually inject these values during runtime, and we will see how to do that when we use the Docker run command. Once we build the image, we will see that, and also in production, we will see that tomorrow. And once we set the environment variable, so these are the dummy values, and then we finally expose. So these expose instruction is telling the users or anyone who is seeing this Docker file or the different processes that this application will run on port 5050, right? So since our default port for the Node.js application that we're using here is 5050, we can expose that. And by the way, if you were listening on some other ports, like if you have 3000 over here, right? So in that case, what you need to do is you need to change this to 3000. So whatever your server listens on, you need to change that in the Docker file as well, and then use that in expose. And finally, we since we now have, let's recap what we have done. We have our Alpine based image. We installed Node, which comes out of the box with this image, and then we set up a work directory. We copied the packages. We installed the dependencies. We copied the rest of the application code. So, and we also set up some dummy environment variables. So now our application has almost everything that it needs to run. So we use the node server.js command, and this command is actually used to start our application, right? We can also use the npm start command from package.json, because we have set it to the same command. So ultimately, npm start will also do node server or server.js. So that's going to be the same, but we are here explicitly saying it to start the application. And then finally, the application will start inside the container. I hope this was clear. So let us now see how you can actually build this. So I'll open up my terminal. I'll open up my terminal. Just give me a second, and I will go inside the app/server directory. So now I'm inside the server directory because there is the location for the Docker file. And now I'm going to build this. And in order to build this, I'm going to use the Docker build command. I am using the instruction that I've already provided in the Notion page. So please check that and refer to that for all these instructions. So here what we are doing is that we are using the Docker build command and providing the tag. So this is actually gonna be the name of my image. So that's gonna be mon employer app and backend. So this is gonna be the name of my image. You could name it whatever you want, but whenever you are running the application, please also make sure that you use the same image name. So for consistency, I'm going to use the same name that is in my Notion page, and this is going to be the version separated by the colon. So this is going to be my image name, and then the tag is actually the version for our application. And since we are already inside the server folder where there is the location for Docker file, I will provide you the build context, which is dot in this case. But let's say if you had Docker file in some other path, then you should provide path to Docker file over here. But since my case, I'm already inside the server, I'm just going to use dot. All right. So this will build my Docker image, and you can see that it is building one by one, right? So since I already built this image previously, the build process was very fast because it did not take a lot of time. And you can see that it even cached like some of the layers, right? So I was talking about the layers and how you should uh, always try to minimize your Docker file. This is the reason, because I did not almost change. I just changed the Docker file, right? Docker ignore file. Nothing else was changed. So from it used the first layer, and then since if you go to Docker file in after there we copy the package and then the dependencies. All of these was cached. You can see that the working directory was cached. The copying of dependency was cached because I did not change the package.json file, and only finally the this copy instruction dot dot, since I changed the Docker ignore module, so that was modified. So that is why it re-executed everything that was below that. So other than that, it was very fast. So now my image is built. So let us go over terminal and check that using Docker images. And you can see that I do have that image over here. So my image and then the version as well as the image ID, right? So that is the image that I have. And also whenever you write your own Docker file, try to use the base layer as much as light that you can. So since Alpine is supposed to be a very lightweight Linux version, so it might not always have all the tools that you need for your application to run, but in my case it does. So I use the Alpine. So what is recommended in production and what is very good practice is that you just use the lightweight minimum Linux based distro for your application image, and then install whatever is required after you take this base image. So in the following instruction, you can install whatever tools or libraries you might need, but always take a very lightweight Linux image as a base image, as if that is possible for your application. So it might not always work, but that's a very good practice. So now I already have my image, right? So we built the image for our backend. We confirmed that. So now let us also do the same thing for our client, right? So let us go to client, and even in the for the client, like I'm inside the client folder right now, and there is a Docker file for the client. So let us just quickly glance through this, because it's almost the same, right, for the client as well, since it is also a React application. Just a few parameters and the command might change, but everything else is going to be same. But here there is a very important concept that I want to introduce here. So we are for the front end, we are going to use a concept of multi-stage build, and I will tell you why do we do that in just a second. So the first instruction is always the same, right? So for the since this is also based in React, so we are going to which is again based on the Node.js packages. Since for client, we are just not using the simple React application, create React app. We are also using the Vite as our development server, right? So in development, since I'm using Vite, and which indeed utilizes the JS as the backend technology, so we are installing Node in order to run that as a backend service. Since Vite will actually serve our front end assets, so we are using that. Forget about as built for now. So just focus on this. Again, the same thing, we are setting up a directory inside the container where our contents will be copied. And same thing, we are copying the package.json. If you go to package.json, you can see that we have React and React DOM as our dependencies. And then again, we have different development dependencies as well. So we don't need these dependencies in production, right? So please keep this in mind, that the dev dependencies are only there during the development process. We don't want our Node.js modules, Node modules to be populated with all of these when we do this in production, because these are only for development. When we do it in production, we don't need any of these. Otherwise, our Node modules will be super heavy, and we don't want that. So that is why in dev dependency, you can see a lot of linting libraries. You can also see Tailwind, CSS. We can also see the Vite, right? So all of these is there as a dev dependency. Again, we will copy that and we will install the dependencies. And here you can see that we are only using the dependencies that is required for production. So we will not be using things like white or tailwind for our container image, because we don't want that. Again, like previously, we copied the rest of the application code only after we install the packages. That's a really good practice that you should follow. Only copy the rest of the code after you install the dependency. And we are also setting up the environment variable here also, because for our client, we need to set up the backend API URL under the .env file. So this is what will tell our React application or a Byte server that this is the URL or the server URL that you need to connect to get your assets or API calls, whatever your front end will do API calls to your backend to get. In our case, it will get the records of the employees from the backend, and the backend will communicate to the MongoDB database to actually get that record. So this is the URL. Since our application is running on port 5050, so that was the backend port, right? Remember the port for the backend. So it's going to be that. So we set up the backend port as well, and also we sorry, not that file. We are going to go over here. So we copied, we installed the packages, we copied the rest of the file, and here we are instead of the env. So if you look at the server, we were using the env instruction, right? And these are actually the runtime instruction. So if you use env, then those are always provided during runtime. So that is why I put here the dummy value and not the actual values, because I don't want this to be exposed, right? So these are the runtime variables. And if you want to use build variable or the variable that is required during the build process itself, so since we need to build our React application, right? For Node, we simply run it. We don't build our backend Express application. We run our Express. Once we have the dependency, we run our Express application. But for React, we are using White, and White is used to build our React application. So that is why we need the White API URL as the build argument. And for build argument, we use the ARG instruction instead of env. And again, after we set the instruction, we are actually doing the npm run build command, and this will actually build our React application. And since we set up the White API URL as an argument, it will be available during the build process. Again, here we don't provide any value in the command itself, or in the Docker file itself. We'll provide the value of the Byte API URL during the build process, and I will show you how to do that. So when I use the Docker build command, I will provide the value during that time and not now. So just letting Docker know that there is a build variable, but the value will be provided later. And please remember the difference between ARG and build. ARG is used for build time variables. So this will be available during build instructions. And also whatever the value you put here will ultimately be exposed in container. So please do not put any secrets, since the API URL is not going to be secret, because it's ultimately the endpoint where the front end will make requests, which is anyway exposed to your end user. When they use it in your browser, they will make a request to the backend, and you can always check that in the network tabs, or if you inspect the website and if you go to the network tabs, then you will be able to see the backend URL always. So that's not super secret. So that is why I'm setting it up as a build argument. But for anything secret that you need only during the runtime and not build time, you need to use the env instruction. So we build the application, and now if you have used React before, if you run npm run build, and if that's the React application, your static assets, so your instead of all these JSX file, so in React you will have the JSX file, right? A lot of JSX file. So in after you build your React application, it's not going to be that. It's going to be just HTML, CSS, and JavaScript. So whatever front end framework you use, ultimately once you build the front end framework, like build the front end application, it's going to be just HTML, CSS, and then JavaScript, right? So it will be inside the dist folder if you're using React. So that is why, let me go back to Docker file. So once we have the dist folder, that's the static assets, right? So why should we keep all the React files in our container image, right? At the end, we don't even need the React files or the Node modules, because at the end, we are just going to get the HTML, CSS, and JavaScript for the front-end application. So why not just simply use those static files rather than all the source code for my React application? So that is why we use the concept of multi-stage build. And here we come back to the build instruction. So this was actually the first stage. So until first stage, what we are doing, we are just generating the dist folder, and it has all the assets that we need to serve our application. And we name the first stage as build. So this is basically a nickname for the first stage. So if you are using multi-stage build, then you need to use the as instruction and provide it a name, right? So this, and now we have another from instruction, right? So I said that any Docker file begins with a from, but if there is another from statement, then it is always using the concept of multi-stage build. So what we are doing here is that, again, in the second stage, we are taking up Alpine based image, but this time we are using Nginx, which is a static server. I'll answer your question, Mohit, in just a second. Just let me complete this portion first, and then I will come back to your question. Okay, so first we built our React application, and it has now produced a dist folder which has the static content, right? And in the second stage, we are using Nginx, which is a web server, and you can use this to serve your static contents. Nginx is, by the way, a very powerful web server which is used for almost a lot of applications. You can not only use it to serve static contents like HTML, CSS, and JS, but also to use as a reverse proxy. You can also use it as a load balancer, but in our case, we are using it to serve the static content. So we are using again the Nginx image, and we are using the Alpine based version, right? And we are copying everything that was produced after the successful execution of the build stage, right? So copy dash dash from. So whatever was there at the end of the first stage, which is actually the dist folder, right? So the slash dist folder, it will be we are copying the slash app slash dist, right? So this folder will be produced if you run the npm run build command, and we are copying that dist folder and only the dist folder and nothing else. We don't need the JSX file, the node modules, or whatever is there in the source code, and we are copying that to the path where the Nginx needs that static assets, right? So this is the standard path which is required by Nginx, and here you put all the static contents. And once you put it in the Nginx specified path, you can find the instruction on where to put this from the official Nginx Docker Hub documentation. You will be able to know and understand which path is required. And Nginx by default runs on port 80 or 443 if you're using the HTTPS protocol. And we are starting the Nginx server using Nginx -c, and then we are starting the Nginx daemon. So this will only serve the file. And now, earlier, please remember that our application or the client could backend was running in port 5050. Similarly, the front end could have run in port 5173 or anything. But now we don't need any of that, because we just need the dist folder which was built from first stage, and then we are exposing that using Nginx, and ultimately your application will be available on port 80 instead. So that is why we just have one expose, because it is actually sorted by Nginx. So your image will not contain any of the React files. It's just gonna contain the compiled file. I hope this makes it very clear. Please, this is a very important concept and super cool to know as well. So let us go ahead and actually build this as well. So I'm going to go inside the client folder, right? All right, so I'm inside the client folder now, and again I will do docker build, right? So I'm going to do docker build, and this time let me do a multi-line instruction instead. Okay, so here you can see that I'm again using the same instruction, right? So the multi docker build command, nothing new. We are giving it a tag. So this is going to be a front end, the name of the image, and then the specific tag, and backslash is used to do write multi-line command in bash, right? So if you are using terminal, and if you want to pass your instruction instead of a single line in multi-line, you just use a backslash, and we are providing it a dash dash build arg, right? And here we need to provide the value of the arg that we set up, right? So I said that in Dockerfile, we don't provide the value. We just provided the name of the variable or the argument, right? Since this is a build time argument, so since we are using the docker build command, so we need to provide it now, because docker build is the instruction to build your application. And since arg is a build time argument, you need to provide the value now. So build API URL, which needs to match this argument, equals to, so we provide it the API link, right? So we provide it the name of the link, and here we are providing the API URL as 3000, right? So remember that we are setting up API URL as 3000. So this means that our backend will also need to run an API 3000, which we'll do in just a second. We will run our backend application also in port 3000, because we set it up as a front end. Or you could also do reverse. You could first run your backend application in any port that you want, because we set it up as an environment variable. So whatever your port your container is exposed to, you need to provide the same port here as well, so same value. So in this case, we are doing it in the reverse way. So we first set up the port in the front end for our backend. So we need to ensure, or we need to make sure that the backend is also listening on port 3000. And then we need to provide it the path where the Docker file is stored. Since I'm already inside client, you can see that I'm already inside the client folder. So I will just put dot, and this will build my front end. So again, my front end is built. You can see that it has cached some of the previous layers. So if I do Docker images now I have both the images for my front end and my back end. All right, so now let us go ahead and actually run the front end, right? So let us go ahead and run my front end. um, but before that, here is a cool thing that you need to know. uh, Previously, if you have watched my previous session, yesterday's session, you already know that by default all the containers that we run will be in the default breeze network, right? So they will all be able to communicate to each other using the container IP address, right? So that's the default breeze network. But since our application here, uh, it might not always communicate using the container IP, and in this case it actually might communicate using the host name. We need to make sure that these are in a custom breeze network instead of a default breeze network. So just for segregation, you could also use the default breeze network and the communication might work just fine. But just for recommendation, we will create a new network so that we can put both of the container in the same network, so that the communication will be easier, and also it's very easier for us to manage later on. We just group all the containers which are related in one network so that they can communicate with each other easily. So that is what we are going to do, right? So we are going to first create a network. So I'm going to use the breeze driver. If you don't understand what I'm doing right now, please go ahead and rewatch the first session. So we are going to create a breeze network, and we are going to name it as mon app, right? So that is going to be since it already exists, I guess I already have that network. Let me do docker network ls. Yeah, so since I already have that network, I can show you the entire process as well. I'll remove the network first, and again I will create the new network. So here you can see that we have created the network, and if I do docker network ls, yeah, here you can see that we have created a new network. So once we have created a new network, we can put run both the containers in the same network so that they will be able to communicate with each other. So that is what we are going to do. So first we'll run the backend, and this might look a bit scary, but it is not. Trust me, it is not. All right. So again, this is the instruction that we will use to run our application. So it's going to be the docker run command, and that's dp. So we learned about this yesterday. So dash d here stands for detached mode. So this means that our container will run in the background process without occupying my terminal, because I do want to run other commands. So I don't want it to hijack my terminal. So I'm running it as a detached process, and dash p here represents the port mapping. We talked about this yesterday, right? So whatever is in the left hand side, it always going to be the host port, and whatever is in the right hand side, it's always going to be the container port, right? So earlier we learned that for backend, if you go to docker file, the backend is running on port 5050, right? So this is always going to be the same port. So on the right hand side, you need to put the port where the container is actually running, and on the left hand side, you need to put the port where you want to access it from the host. So since it's my PC and I'm going to access it from the browser, so I'm going to need to put the port where I want to access it from the host. So whenever I do localhost port 3000, it will forward all the requests to actually container and on port 5050. So that is why I will be able to access the container from the host. Otherwise, if I just skip the dash p part and provide no port, then I will never be able to access the container directly from the host, because we need to do a port mapping from host to container. Yeah, so that is what we do. And we provide the name for our container using dash dash name flag, and we also specify that it should be in the mon app network, which we just created once a few moment ago. And now we need to provide the environment variable, right? Because I said that env is a runtime environment. For client, remember what we did? For client, we used the arg instruction, and we provided that value during the build time, right? And we provided the value of the byte area url as localhost port 3000, and that is why we are running the server application on port 3000. So the container will itself run on port 5050, but from the host it is accessible on port 3000, and that is what we need to put it for our client as well, because client is gonna run on the browser and it needs to be accessible from the host as well. So that's why we put 3000 earlier. But for the env variable, we need to set it up during the runtime, and since we are using the docker run command, so this is the runtime instruction. So that is why we need to put the atlas url value over here. Since port 5050, we also set up the default value. We are skipping that environment variable, but if you want to change that, then you can add another dash e flag and also change the value of the port that you want to your container to run. But in that case, please also make sure that you change the value over here. So let's say you want to run your backend on port 6000, then you need to add dash e and then port equals to 6000, and also 3000 is mapped to 6000. So you need to do it like that. So just a second. So I'm going to replace this atlas URI with my actual URI that I have. So you are going to have to replace this inside the inverted comma. So I have that in my config.env. So I'm just going to copy the value, the entire value, and I'm going to paste it over here. So now that that is copied, I can run this, and you can see that the container is already running, right? So I can see that my container is already running, so that backend is already accessible. So also I will do the same thing for my client, right? So I also need to run the client. So let me go ahead and run my client. So similarly, the same way like we did for the front end, I already have my backend running. So for the client as well, since we have the image, docker run dash p, and since client is running on port 80, right? Remember the client docker file for the client, we are just using nginx to solve the static content on port 80. So that is why we are just putting the container port as port 80, and it is mapped to port 4000 on the host. So if I want to access the client from my browser, I need to go to localhost port 4000 because that is the host port, right? And again, the name for my container, the network. Remember, both the front end and the back end are in the same network. So we need to put them in the same network so that they can communicate. And again, this is the name of the image, right? The mon employer app front end and the tag, so that we use during the build process. So now both my applications should be running. You can see that both my front end and the back end is running fine. I could just expand this or make it a bit smaller. Yeah, you can see that both have the container ID, and my front end is running on port 4000 while my backend is running on port 3000. So let us go ahead and verify this. All right. So I'll open up here and localhost port 3000. That was the port where my server is running, right? And you can see that the server is running fine. I can go to /record to view all the records, and you can see that the records are fetched from the database. So that means that the database connection was also successful. And my front end, if you go to the terminal, I think the front end is running on port 4000, right? So the front end is exposed on port 4000. So if I want to access the front end, then I need to go to localhost 4000, and here you can see that I have the front end. So this is the simple employee app. I can delete, I can add employee records, I can create a new employee and add records. I'm not going to do that over here. I might delete some records. Yeah, so this is the front end, and this concludes how you can write and build your own Docker files, right? So that is done. We have covered that. So let us go back to the demo and see what we have to do next. All right. So I hope this is clear, and we do have a questions from this part of the session. So let me just quickly check that. What if we are using MongoDB container as database for backend? All right, that's a really good question. So if you're running MongoDB as a container, so you are going to have 3 container instead of 2, right? So you are going to have custom Docker file for 2 of them. So you are still going to have 2 Docker file for your front end and back end, but you can already use the publicly available MongoDB image, right? So you could go to Docker Hub and search for MongoDB. So once you search for that, you can pull that MongoDB image in your own local machine. So now you're going to have 3 containers, but 2 of them is custom made and 1 is publicly available. So what you need to do is that you need to put all the containers within the same network. So in my demo, I put 2 of the container in the same network, right? So you also need to put the MongoDB container in the same network. So that is the one additional thing that you need to do. And also, in order to run the MongoDB container, so if you go to the official Docker Hub documentation, when you use the docker run command, so there is going to be some environment variable that you need to set, right? So even for our demo, we set up some environment variable for our backend, right? So when we use docker run, we provided it the MongoDB URI. So similarly, if you run the MongoDB container itself and not use it from the Atlas, you are going to need some environment variable, which is mainly setting up the database user and the password and the name of the database that you want. So you're going to provide that as an environment variable. And once you have all of that configured, you can use the name of the MongoDB container as the MongoDB URI instead. So instead of the MongoDB URI, so the full URI link that you have, you can use the name of the container itself and the port. So the name of the container and the port where the MongoDB is going to run, you need to provide that as the value of the MongoDB URI instead of that last URI. So you can find all of this instruction in the official MongoDB documentation. I hope that answers your question, Mohit. And that's a really good question. But please make sure that all of these containers are within the same network and you set up the environment variable properly. And that is super helpful. A good question. All right. So before we start Docker Compose, so right now you saw how we built the image and then we also executed or we ran the Docker container by the command line, right? So we typed in the Docker build command, we typed in the Docker run command, and it was a lot of hassle because we need to use multiple lines, we need to set up a lot of argument. And don't you think that if there was like 10 containers, then this would have been very hassle? Like you need to do Docker build 10 times. You need to make sure that the arguments are set up correctly. You need to also do Docker run 10 times. You might also need to create Docker network. Right? You need to do all of this manually, and that's going to be a lot of time. And that is what Docker Compose is used for. It's a wonderful tool for defining and running multiple containers. So instead of typing Docker commands to build our application and to run our application in the terminal, we just write the configuration in the YAML file, and that is what is used to configure our application. So it will automatically build the image if there is none, and if there is already the image, it will use that image and it will run the application according to the instruction that we set. So it's very reusable, and it is also a bit scalable, right? So but once you have, let's say, once you go into the terms of microservices and once you have a lot of container, even Docker Compose will not be enough, and you will need a proper container orchestration platform like Kubernetes. So that's out of the scope for the stream, but Docker Compose itself is pretty helpful. So and right now you remember that we needed to create a Docker network for our containers to communicate, right? For the front end to communicate with backend, we created a manual network. Docker Compose will do that automatically for you, so you don't even need to create a network at all. So that is what you will do. All right. So all right, before this we just have one more question. What was the front end port you used in Docker build command? So I have to check that. I guess I used like port 80 for my Docker file. So port 80 is actually used to build my application. But when I run it, like when I run the Docker container, then I exposed it on port 4000 on the host side. So for building, since it is using Nginx, which is exposed on port 80 by default, we are not using the React files. Remember that we are done with the React process in the first stage itself. So we are just using the static content from the dist folder, right? So we're exposing it on port 80, and then I'm mapping it to port 4000 on the host. I hope that answers your questions. All right. So before we get into the nits and bits of Docker Compose and how we can skip the manual Docker build and the Docker run process for multiple containers and automate it with the file, just let us take a quick 2 to 3 minutes break, and I will be back in no time. Please grab some coffee or tea or whatever water you want. Then I will be back in just a second. All right, welcome back, everyone. Give me a second. My monitor is behaving weirdly. Just give me a second, folks. All right, so I am back again. So we're talking about Docker Compose and how it can help us run multiple containers at once. So this is a basic example, but instead of the code here, I'm going to explain it from the demo itself. So let us go ahead and see the demo for Docker Compose. All right, let me go back to my code section. I'm going to clear this up. I'm going to close all the files. Just a second. Close all. And now I don't want to save anything. And then let me pull up the Docker Compose. And remember that the path I have mentioned over here. So everything is inside the client and server folder, right? For the client and server, effectively inside the app folder. So I have written Docker compose.yaml. So it's the special name which is reserved for compose. So you can also use docker dash compose, but nowadays the preferred one is compose.yaml to write your compose file. So similarly for Docker file, it had to be Docker file, right? So starting with capital D and then Docker file with no extension. So that was for Docker file, but for compose, this is actually the small case. So compose.yaml or docker-compose.yaml. Even if you don't use this name, you can use other names, but if you use other name, then you need to provide that explicitly when you use the docker compose command. All right, so let us see what is there we have. So basically what we needed was we needed two containers, right? So we needed a container for our backend and we also needed a container for our front end. We built the front end and client backend containers with respective arguments, and then also we ran it using the respective environment variables and configuration. We created a network to ensure that we both of them are in the same network and they can communicate, right? So here what we are doing is we are going to put all of that configuration in a single file. So the containers are defined under the services section. So this is a YAML file, which is based on the key value format. So if you don't know YAML, I would highly recommend you to learn YAML, but it is very simple to understand. So everything on the same label define the same like the parameters. Like, so if you see, you have services, right? So, and under services, we have two different services. So the first one is the Node.js API, which is the backend, and the second we have the React app, which is the front end, right? So that is actually the two different containers that we are going to use. So that is the containers that we are going to use. So whatever containers that you are going to use, so that will needs to be specified in the services section. So inside the container, so first we need to provide it a build context. So first specify build and then the context, and the context is always going to be the path to the Docker file, right? So even when we use the Docker build command, we provided the build context, which we use, which was usually dot, because we are running the instruction from the same folder. But here, since the compose file is in the different folder, right? It's in the root of my project, but the server is inside app/server, right? And here it is the Docker file. So you need to provide it the path where there is the Docker file for our server. So that is what we did over here. And we have kept it restart as always. So this means that whenever you restart, whenever your container crashes, it automatically tries to restart itself. You can set it to false as well, but for the sake of the demonstration, I've kept it as always. You can set it to a different value as well, as never as well. So then we need to specify the port. So this is exactly the kind of port mapping that we did earlier. So earlier we mapped port 5050, that was the server container port, and we mapped it to port 3000 on host. And here I'm doing the same port. So remember that the first on the left hand side is the host port, and on the right hand side is the container port. Since the container is running on port 5050, even at the host, and this time I'm using the same port, port 5050. But remember, these are different ports. This right hand side is the container port, and then left hand side is the host port. And here I have created a network. So you can see that on the network I have created app-network, but I don't need to create this manually from the terminal. So if you specify it on the network, the app-network, and at the same level as services, so on the same level as services, we have defined the network, right? App-network, and we have also specified that it needs to use the bridge as the network driver. So all of this will be handled by Docker Compose. It will create an app-network, and it will ensure that the Node.js API is kept in the app-network. And for the env file, so remember that we provided for the backend, we provided the -e flag for to place our MongoDB URI. So we are now going to use the docker.env file, and here we will provide the atlas.uri and the port, right? So it will use the value from the docker.env to actually run the container whenever the image is built, right? So Docker Compose not only builds your container, it also starts your container, right? So when it starts the container, it will load the value from the env file, and the env file has the, sorry, not that, the docker.env file has the atlas.uri value. All right. We do have some questions in the chat. Let me just quickly glance that I guess there are some debugging questions, and I guess the other members have already helped. Okay, I am not sure what that is, but that might be some. Um, mhm. Yeah, so that there might be some confusion regarding the order in which you need to execute different things. So please remember that first you need to build your application image. So that is super important. You cannot start your container, run your container without building. So first you need to build your applications container, and even for building there is a logical flow that since your backend depends, sorry, your front end depends on backend, it needs to make those API requests. It's highly recommended to build your backend image first, and then you will have and then start your backend. So once you build the backend, you start your backend, right? So it will be a running Docker process. So once both of those is that is completed, only then you build your front end image, right? Because you need to provide it the API URL during the build process itself, right? So you need to know the port where your backend is running. So you need to know the backend URL already when you build the container image for your front end. So first build the backend image, run the backend container, then and third you build the front end image, and finally you run the client application, so the client container. So that is how the flow works. I hope that makes things clear. All right, so in the second service, so this is going to be the second container. So since the Node.js API and React app are on the same level, so these are the second container. So any number of containers you want, you need to put them in the same label. And again, for the context, so we are providing it the path to the Docker file for the client, which is inside/app/client. And this time, since earlier we used the env file, so these are the runtime environment. And for build arguments, since white API URL, like I said, at least I don't know, I said it 5 times, I believe. This is a build time argument, so you need to provide it in args under the build process itself. So under the build itself, you need to provide the arg, and the value is going to be the white API URL. So you will use again, this will be populated. You need to populate this from the so if you use dollar and then the value or the key, so this will always be taken from the .env. So you need to have a .env file in the root as well, and here you can place the white API URL and the value for it. And when you do docker compose up, that's the command which you need to start and build the container. So if you use dollar, so it will populate the value from the .env file. For backend, for the backend, we populated the value from docker.env, but for front end, the build argument, we are using the .env file to store the value for white API URL. Again, this is also restart always. So again, if the container crashes by some reason, it will try to restart itself. The port is again 8080. So this means that the container post 80 is also mapped to container the port 80 on the host itself. So if I go to my browser, then I need to go to localhost 80 to access the client application. And by default, I guess since all of you or most of you might know that localhost 80 is the localhost itself. So local, when you just type localhost in your browser, it is always port 80 by default, right? So you don't need to even type port 80, but yeah, it's going to be running on port 80. And again, I'm putting it in the same network as backend. Remember, both of them are in the same network. And I have kept a flag that it depends on the Node.js API. So this will ensure that first the backend API is successfully built and ran. Only then it will make sure that the React application is started. So it will wait for the Node.js service to be healthy before starting that. And you can also specify different additional health check commands, which is out of the scope for this tutorial, but you can check out the documentation on how you can actually write your own custom health check commands to ensure that your backend is healthy. And then finally, I already said that we have a network. You need to define the network separately. So here you only specify which network you use, but if you specify it under here, then Docker Compose will create that network if you don't already have that. All right. So that was about the Docker Compose. Now let us go ahead and see the magic, right? So I said that if you use Docker Compose, let me do one thing. Let me actually do Docker PS. All right. So I will remove both the container, right? So I will remove the container, both the containers. So that's going to be mon app frontend 1.0. I'm going to forcefully remove it. There's no such container. Mon employer app, I believe. That was a mistype. Mon employer app, right? Even this is not over there. I don't know what is wrong with this. Mon app frontend should be the answer. Sorry. So I was using the image name instead. So for RM, you need to provide it the name of the container instead. So that is removed. And similarly, I'm going to remove the backend container, right? And what even I'm going to do is that I'm going to remove both the images that we built as well. Docker images, and I'm going to remove both the images. I'm going to use the image ID, right? Not that. Just a second. Copy the image ID, and also the next one 7e3c. By the way, you could also use a few characters and it will be removed. So now I don't even have like the container nor the images, right? So I don't even have anything for this application. So now let us see the power of Docker Compose. So let me go to the root folder first. Again, one step back. So now I'm inside the same path as my Docker Compose. So I'm going to use the command Docker Compose and then up, right? So and this is the command that you need to start the containers from Compose. So what this is going to do, if you see over here, right? So it's gonna first build the image. Since there is no image in my local machine, it is actually going to build both my both the image for my backend as well as the front end. So if you see over here, it is building the different images, right? And once it built the image, then it is also set up the network, right? So it created the network that we talked earlier, and then once the network is created, only then it started the application. And you can see that it first started the Node.js application, and then it started the React application. So this means that our application is now up and running. You can see the logs over here as well, and the server is also ready to start. And if I go create a new terminal, like, and I can do docker ps, you can see that now I have both the container up and running, right? And I can even do docker images, and you can see that I have both the images as well. And also I can do docker network ls to see if the network was created, Docker network ls, and you can see that we also have the mon stack application app task network, right? So that was the network which was created. By default, Docker Compose always prefix the parent folder name before your application. So you can see that under the network, it is prefixed with this is the name of the parent folder, right? And then the name of the network. So this was the app network, which is over here, right? So it prefixes that automatically for you. So that means that our application should be all up and running. So let us go ahead and check that. So uh, uh, in this case, I told you that the client would run on port 80, right? Which is like this, but I could just use localhost only. And you can see that it is working properly fine. So this means that it is making API requests to my backend, which you can confirm by opening up an inspect tab, right? So if you open inspect tab and under network, if I load this again, you can see that for fetching the records, which is under /record URL, I will zoom this up for you all. It is actually sending the request to HTTP localhost 5050/record, which is actually the API where the record is loaded, right? So that means that it's able to connect to our backend. I can also go to the backend port, which I guess was running on port 5050. So this is the host port. Remember, this is the host port, and in this case, both the host port and the container port are same. So port 5050 on host, it will forward the request to container running on port 5050. Again, the server is also running, and I can get the record by going to /record route, and I can see the records. Right. So we have completed Docker Compose as well. So that is awesome. And please remember that if you are going to not only for this project, if you're going to build projects and run containers, Docker Compose is always going to be handy tool. But for the concepts that I've covered today in this session, right? So we covered about how you can containerize your application, how you can write your own Docker file, how you can start container, how you can build them, how you can even run multiple containers using Docker Compose. The concept is going to be the same, even if you are going to work in DevOps or cloud, even in the future, or even as a developer, you might need this. So it's really helpful tool to learn. All right. So next up, what we are, yeah. By the way, like Mohit have mentioned, providing the byte API URL in this way as well. I would recommend you to use env variable .env file in the root because that will be taken up automatically. but you could use like provide that in the argument when using Docker Compose up as well. So that's another way, but normally you can provide a file, and please don't commit that file to GitHub. You don't want that to expose. You just use it during your development environment. That's a lot easy rather than populating the variable every time. So that's another way as well. Totally fine. So now let us see how you can actually publish this image, because we have already created the image, and now it's time to actually share this to other, right? Because we are not just going to use the image for our own, we are going to use it to deploy our application to production. So our production server will need our access to the images, and we might also want to share that to the public or to other developers. So we need to store it somewhere, right? So for code we use things like GitHub and the GitLab and other version control repositories, but for image we upload it to registries. So for publishing image we upload it to registry, and there are two different kind of registry. The first one is the private registry, which is normally used for if you're working in a company or a production application, so you don't want um, public to be able to use your image, right? Because your image contain the application code which you don't want general public to know. So if it's a closed source product, then you will not be able to see this. So those are stored in the private registry. So some of the examples are the Amazon Elastic Container Registry. So that's the logo for this one. The middle one, which is the Azure Container Registry, and that is something that we'll use today itself in the demo. So we are going to use the Azure Container Registry and also the Google Cloud Registry. So these three are the most popular private ones. But by default, like I said, Docker Hub is the public registry. So you can use it to get public images as well. But also in the free plan, you can also use it to store private images. But Docker Hub only allows you to store one private image. So if you want your image to be private and not accessible by anyone else, you only get one option but in the free tier. But if you pay for the higher subscription, then you will be able to store private images over there as well. So docker.io, which is the your default repository for all the images. So when you actually want to authenticate to Docker Hub, if you want to, let's say, publish your public image or one private image to Docker Hub, then you can use the Docker login command, and you need to provide it the repository name. So dash repo name and repository name. So if you don't provide anything, then Docker login will automatically take you to log into Docker Hub itself. So you can try this in your terminal right now as well. So if you go to your terminal and type Docker login, it will open up a browser and it will take you to Docker Hub. So there you need to create your account and login, and your terminal will be connected to your Docker Hub account, and then you can use it to publish your own image. And you need to provide it your username and then password. And once you have that, you can't just simply push it like we do in GitHub. We can just simply push our code. We need to retag our image to a certain format, and for that we use the Docker tag, which we will see in the demo. And then the current name that we want, right? So current name in the version of our image that we have, we need to retag it in a specific format. So the format is always going to be the repo name. So the name of the repo that you have and the image version that you have. So this repo name will be provided, depends on the type of registry that you use. So for Docker, it's going to be docker.io. For Azure, it's going to be a different one. So you need to provide that, and it's also need to match the repo name and the image version, and you need to finally you can push the image. So that is how it works. So let's say for public image, when you do Docker pull Mongo, for example, and you pull the 4.2 tag, behind the scene into actually prefixing that with docker.io/library. So this is the actually the full path for your Docker image, and it will actually pull it from the Docker Hub because you did not specify any repo. But for example, if you want to pull some private images, then it's going to look something like this. So this a long string that we have on the left hand side is actually the URI for your Amazon Container Registry. So that's going to be the registry URI, right? So and then you have the finally the image name and the tag. So this the whatever is there before your image name, it depends on the type of registry that you use. All right, so let's go ahead and see this in demo. All right, and that is the final section for today. So we are going to just see the demo and then conclude the section. So for this, you will need to use Microsoft Azure, and please go ahead and create a Microsoft account for students if you have not already. You will, for students, you will get $100 free credit, which is more than enough for all the thing that we will do today, tomorrow, and even yesterday what we did. So go ahead and sign up for that, and always use the free tier or the low tier service. And remember to close the resources and shut down the services once you have used it, so that you don't use all your credits that you have. All right, so once you are in the Azure, by the way, also the URI to register for Azure and everything is in the folder that I have. So all the instructions are also over here in the Notion page. All right. So let me go to Azure, and now I'm inside the Azure dashboard. So what I need to do is create something called Azure Container Registry. So I'll click on create a resource and I'll search for container registry. So let me go ahead and click that. Yeah, I chose to show you in Azure Container Registry because tomorrow we are going to publish this image, deploy this image in Azure Container Apps. And since my images will already be there in Azure Container Registry, it's going to be very easy. By the way, you could also use external registries and still deploy it in Azure using Azure Container App, but that's going to require some additional authentication mechanism because your app will be running in one cloud environment, but your image will be in a different private registry, so that might create issue. If you're using a public image and pushing it to Docker Hub, that's no issue. But if you're using a private Docker Hub registry, so authentication might be some additional hassle, which I don't want to cover in this demo. So that is why I chose to use Azure to store the private image, because we are going to run in Azure itself tomorrow. So I'm going to click on container registry, and then I'm going to create one. It's a very pretty simple forward. You need to put it in some resource group, right? So resource group is not nothing but just a folder, or like think of it as a folder for all the collected services that you will use in Azure. So I'm going to put it in the GSWMon resource group. You can create a new one as well, give it a random name. So I used this resource to deploy my application yesterday, so that is why I chose the same resource group. But you can create a new one, not a problem. And now give a name for a registry, right? So you can see that it is appended by .azureci.io. So I'm going to give it a name. So that's going to be GSWMon. So first I need to create two different registry. So one for do GSWMon backend, the location, choose whatever is nearest to your location or where your application will run. So that will reduce the latency. And I'm going to click the pricing plan. You could choose basic, but since I have some credits left, I'll choose standard, but you can, basic is also totally fine. And then I'll click review and create, and then I'll just, once the validation is complete, I'll just create that. It will just be completed in a few seconds, and then this should be done. So the deployment is in progress, and it should be done, right? So in the meantime, let us go ahead and create a second repo while that is being created, right? Because we also need the one for front end as well. So again, container registry, right? So let us go ahead and create one for the front end as well. So I'm going to go there. I'm going to go use the same resource group. So this is going to be GSWMon front end, right? The location is going to be same. Again, everything is same. So we just created two different registries, right? So yeah, I can see that the deployment is already succeeded for some of them. So this is our backend registry. So I'll just close this for now and show you. So you can see that this is our backend registry details, and you can get all the different information over here. So the login server, so we are going to use this URL when we push the image, right? And you can see that all the different options that you have. You can see activities like when you did what to this repo and everything. But the most important thing that we want over here is the repository settings. So if you go to repositories, that's super important. So that is where our actually image will be stored. So it will be stored in the repositories section. So yeah, Mohit have mentioned that they don't have a credit card, which you actually don't need. So that's a very good thing about Azure, is that it will provide you the Azure access without a credit card. So if you go to just search for Azure for Students, right? So if you go to Azure for Students, then the first link that you did, you would need a student email though. So and then you will get free $100 Azure credit. I hope this will help you. All right. Even if you don't, you can, for this step, you can even push it to Docker Hub and make it a public, push it as a public image so that you don't need any money or any credit card as well. All right. I hope that helps. Let us go back to the client. So here we will be seeing all the backend repo. So let me go back here. Once I go to the repo resource group, I'll go to the GSWMon resource group. And here you can see that we have two container registry, one for front end and one for backend, right? So I'll open this in two different tabs. All right. So let us wait for this to load. Yeah, you're most welcome, Mohit. Glad to help. So we have two different repositories, GSWMon frontend and then the GSWMon backend, and we have a different login server details over here, right? So for both the frontend and the backend. All right, so let us go ahead and try to push our image. And for that, what we need is something called as Azure CLI. So since we're trying to push this to Azure, so we'll need to have that CLI installed. in our local machine, because that will make this process a lot easier. Again, if you follow my tutorial, then I have provided this instruction in the Notion page as well on how you can install the CLI. So if you go to this link, you will be able to install the CLI for your Linux, Windows, or Mac OS. And then once you have the CLI installed, you will be able to access the AZ command. So let us go ahead and actually do that. I already have the AZ CLI installed on my machine, so I'm going to do AZ. Let me show you the entire process. So first I will log out. So yeah, you need to do AZ login first. So the first instruction that you need to do is AZ login, right? So let us go ahead and log in. And now a browser pop-up has opened. So in my account, a browser pop-up have opened, and just select the ID that you use, right? So let me just sign up to my university account. I guess this one. Yeah. All right. Oh, sorry. Oops, sorry for that. Like I need to install, enter my authentication code. Give me a second. All right. Give me a second. Sorry for this. All right. So that's going to be 127 and 071. All right. So now, yeah, since you can see that I have logged into Microsoft Azure. So if I go back to my terminal, where is my terminal? All right, here. So you can see that it automatically fetches my subscription. So I just have a student subscription. So I'm going to select the number one. So enter one in this case. If you have multiple subscription, you can select accordingly. So now that I have already logged in, so let us go ahead and proceed further. So the next thing that I need to do is to log into my repository, right? So I'm going to use the AZ ACR command, and then I need to use the login AZ ACR login command, and then the name of the repo that we created, right? Name of the registry that we created. So if you go back here, so we created two different registry, right? So we had the front end and the back end. So I need to log into both. So let me first log into the back end, the front end, right? So I will do AZR ACR login, and the name was GSW1 frontend. So I'll log into that. Yeah, so the login is now succeeded. Similarly, I will also log into the backend, right? So it was, I believe, backend. We can confirm that. Yeah, GSW1 backend. So I will also log into this one. Again, all of this command is in the Notion page. So please follow the Notion page. So now that I have logged into Azure and also to my registry, so now I am almost done with pushing these images. So let me retag my images. So your images, if you see now, Docker images, right? So sorry, Docker images, you can see that my image is named in this way, right? But we need to retag it, and the retag is going to be in this specific format. So what we are going to do is, so this is the name that I have right now. So you can see that it's not that as well. So the first, let me go here. The first tag is going to be the current tag, right? So let me just quickly cut this off. Okay. And this is going to be the tag that I want, right? So I'm going to copy this. And also you need to provide the version. All right, so this is going to be the version. So this, sorry, not we, since we both of them is using the latest tag. So if you're using the latest tag, you can skip the latest tag as well. You could write it this way, like latest, but you can skip that as well. But if you have a tag, please make sure to include that. And next up, this was previous autocomplete. Let me actually delete that. Yeah, React app. And now I will copy the login server full path. So this is going to be the login server full path, right? So I need to copy this full path, and then I need to paste it over here. So now that is done. And now I can do slash, and then I can copy like the same format, right? So I can do this. And if I had tag in this case, like 1.0, I need to put it over here, but it's not required for me in my case. So I retagged the image. I will retag the image in the format that is required for Azure. So this is the name of the image. If you had tag, then you need to mention tag. And the second, which is on the right hand side, is gonna be the tag which you want to change. So I changed it according to the format which is required by Azure. So this is gonna be the login server URI and the name of my image and the tag if I had, but I don't have in this case. Yeah, so you can see that my application is now retagged. So if I do Docker images, you can see that I will minimize this. You can see that I have the new retagged version as well. Please remember that both of have the same ID, because those are basically the same image, but we are just making two copies of it, like from the same source, with different names. So I'll similarly I will retag the backend as well. So I'm going to take this, I'm going to just copy this, so I don't have any tag. So, and after that I'm just going to copy the URI, so which is going to be same for front end back end. Oh, I don't think so, right? Yeah, it's a bit different one, right? All right, just a second. So that is going to be a bit different. So that was back end, and this time it's going to be front end, right? You could simply copy to avoid the hassles, and then this is going to be the same name. So I'm going to copy this, right? Yeah, so I'm going to copy this one, and then now I can do enter. So now I have retagged both the images. You can see that I do have a retagged image for my React app as well as Node.js app, right? So now we are ready to push our application image. So since we retagged it properly according to the format which is required by Azure, because you see that the login server is here, so we need to prefix whatever image we have with this one. All right, so now let us actually push the image, right? So so for that, the instruction is pretty simple. So it's docker push command, and then you need to copy the retagged version. So you need to copy the retagged image, and then I'll push this. So you can see that it has now started the push, and this time remember that it's not pushing to Docker Hub, it is pushing to Azure because we retagged it. So it has pushed all the layers, and I'll do similarly for the front end as well. So let me copy this one. Sorry, earlier I pushed for the front end and now for the back end. All right, so now even this is being pushed. So let us wait for this to complete. And I hope that's done. Yeah, both of that is done. So we can check that. So I'm here in my repo. So if I go to repositories again, right? So if I click on repo, you can see that now I have the image over here. If I click on that, you can see that I have the latest image over here under tags, right? So this is the latest tag, but if you change the version like 1.0, 1.2, you will see all the tags, the last, the hashing ID and everything. You can see all the information of when it was modified, when it was last pushed. So everything you will be able to see over here. Similarly, if I go to the backend and repositories, you will also be able to see. I guess I messed up a bit because I think I pushed. Yeah, I messed up a bit here because I pushed the Node.js API to the front end repository and the uh, React app to the backend. So let us actually, let's actually modify that. Like, I'm sorry for that. All right. Okay, let me see what mistake I have done. Yeah, so here you can see that I pushed the React example in the backend URI. So I need to redo that. Sorry for that. Right. Mistakes happens. All right. So I'm going to change this to front end itself. Right. So it's gonna repush the image. Oh, just a second. Man front end is okay. This post refer the image does not exist locally. Just a second. Just a second. Let me see what is happening. And life of developer is also about how to debug things, right? So let me check this again. All right. So we did the tagging part itself in wrong manner, right? So what I'm going to do is I'm going to remove both the image over here. All right, and also this one, Docker RMI, right? And I'm going to retag it in the proper format. So this time I will hopefully not mess this up. All right. That's going to be tag. And then this is actually going to, since it's a React application, I need to publish it to the front end, right? So I'm going to copy this one, front end URI. Oh God. Oh God, my autocomplete is behaving so weird today. Okay. Dot Azure cr.io and then the name of the front end. All right. All right. So this is now tagged properly, and I'll do the same thing for my Node.js API as well. All right. And this is going to be the backend URI. Control C, Control V, and I am going to do again my vo.complete. Sorry for that, folks. Slash, and then I'm going to use the backend API. All right. So now that it is stacked properly, now I can do Docker images again, clear Docker images, and now I can make the proper push. All right. So I'm going to push this. All right, folks. So now we should be good. And also I'll do the same thing for my backend. Docker push. All right. So this should be done. And now let us go ahead and check this if this is actually successful. Yeah, so if I refresh this now, then you should be able to see that now I do get a new repositories, like, so this is the one that we actually want to use. So yeah, so we have proper now for the backend, we have the backend API in the proper registry. So I can just remove the earlier React one. And for the front end, if I refresh it, I should be, yeah, I got the front end repository, right, with the latest tag. So I can simply delete the API. All right. So that is done and everything is done. Like we covered a lot of things. By the way, you could also have a single registry and then you could have multiple front end and the back end within the same registry itself. But in production, there might be many cases where you want to have different container registries. So I showed you how you can do that. So I created two different registry, but ideally you could have a single registry and then within that you could have multiple repositories. All right. So this is done, right? So my front end has my front end image and my backend registry has my backend image. So all of this is done, and you will also get some additional image scanning options and also observability tools with Azure that you can check out on your own. But that is, we have come to the end of the session for today. I hope you all enjoyed a lot. And tomorrow, what we are going to do is we are going to take this to a final stage. We are going to take the image that we built and then we published, and we are going to deploy this container image using Azure Container Apps, sort of a microservice environment. So that is what we are going to do, and that is what we are going to cover tomorrow. So hopefully you will all be there. So please register for the session if you already have not. And yeah, for the final moments, if you have any questions, just let me know right now. Else, I will see you all tomorrow. And do we have any questions? Also, please let me know how was the session. If you all liked it, if you learned something, please let me know in the comments so that I do get the feedback that is super helpful. All right, folks. Yeah, welcome, Cynthia. I hope like you all learned something, at least something. It might be a bit, especially for beginners, a bit too much, but with time you'll get it, and things like this you will always need it in your professional career. So super cool. Cool. Practice, follow the notion that I gave, and that is it. Cool. Do we have anything else, folks? Thank you, everyone. Thank you, Ben. Take off, everyone. Bye bye. Have a great time ahead. Bye bye.